Hi, this is Jason Conoval from Venom Power, and welcome to part 9 of the Venom BCMS video tutorial series. In this video, we will take a closer look at the inventory overview screen and explain the various metrics, filters, and export options that are available. To access the inventory overview screen, we must have an active internet connection, and we can get here by clicking on Inventory in the desktop software, or by logging into our account at www.venombcms.com and clicking Inventory. Starting at the top, you will notice that we have several subpages for faults and maintenance, which we will cover in a future video, but for now let's focus on the batteries page that we landed on. In the Summary section, we are presented with a list of metrics that will update based on our filtered region that we have selected. By default, we are currently viewing all active batteries in our fleet, and the summary metrics reflect this. The meaning for most of these fields is intuitive, however, I wanted to provide a bit of detail for a couple of the metrics shown. The first is the service soon value, which for our account currently shows 3 packs. This field provides users with an indication for the number of batteries in the fleet that will require a baseline test to be run within the next 7 days. This is calculated per the service interval that we set in the battery configuration and considers the last service for each battery pack. Also note that by clicking on this section, the list of packs is filtered to show only those that require service soon. We can clear this filter to show all active packs again by selecting Clear Filters. The next field that I want to talk about from the Summary section is the Cost per Use field, where we divide the cost of all batteries over the total usage count. For Venom Commercial Series BMS batteries, this value uses the discharge cycle captured as the battery is used outside of the BCMS, or any charge cycle that did not occur in the Venom BCMS for the calculation, both of which the battery captures in its onboard data storage. For standard batteries, this field uses charge cycles only to calculate a value, as we consider a battery is most likely to have been used should it require a charge. This information can be especially valuable to provide reporting to the CFO for current rate per use, and also help to show how proper maintenance may extend the life of a battery, thus reducing per flight costs over time. Moving down to the inventory battery section, each battery is listed with the name that we assigned it during the new battery setup process, and next to the name, we are given a health status, which is based on data captured in the maintenance table through running baseline cycles. These statuses include active, degraded, end of life, and faulty. If any of our inventory batteries fall to less than 80% of the first baseline cycle reading, this battery is deemed unhealthy, and the health status message will show here as end of life. This 80% rating is based on industry standards for a generally agreed upon safe end-of-life threshold. The degraded status is calculated in the same manner, however, is triggered at 85%, giving warning that this battery will soon reach the end of its useful life. On the right, each battery is also shown with a status related to the current charger activity, where we will see the battery is either disconnected, idle as shown by the state of charge text in white, charging as noted in green, or discharging as noted in yellow. If a battery is being charged or discharged, we are not given any option to carry out changes to the pack. If a battery is idle, we are only allowed to configure the battery at this level, and if it is disconnected, we are given the options to configure as well as retire the battery. A tip that I would like to add here is that we can rapidly identify the charger and bay any given battery is in as long as it is connected to and configured to the charger. So for example, using our battery 15112_1, which is currently charging, if we click on the state of charge estimation, we are taken to the charger detail screen, and here we can see this battery is in bay 3. Moving back to the inventory screen, in a previous video we had discussed setting up a battery at this level, so let's skip this for now and take a look at the show retired option. As this selection is made, the list of batteries is filtered to only show retired packs, and for each we are given the option to activate the battery, which adds it back to the active list, or permanently delete it from our inventory. Please be aware that as we delete batteries, all associated data is permanently lost. Let's return back to the active list of batteries by selecting Show Active. Next, I want to point out the export feature, which provides us with a summary of usage in CSV format for each battery within our current filter region. Keep this in mind as we continue on, as there are additional filters that can be applied, further refining the list of batteries being viewed based on our needs. Moving along, these additional filters I mentioned are available through the graphical battery status summaries shown on the right side of the page. I can click on any one of these, and as I do, you will notice the list of batteries is updated according to the selection that we just made. As a reminder, we can return back to our default view showing all active batteries by selecting the Show Active, and in some cases this may also show clear filters. Taking a closer look at this section, you will notice that we also have a breakdown for standard and Venom Commercial Series batteries as part of the battery fleet summary. All batteries will be grouped as standard batteries, including DJI packs, except for Venom Commercial Series BMS batteries, which are grouped accordingly. The degraded and end-of-life packs that we mentioned earlier will be grouped here accordingly, and batteries with active or unacknowledged faults will also be grouped here accordingly. The fault history section breaks down faults on a more granular level to show a summary for each fault type, including historic faults, which have been previously acknowledged, as well as active faults, which have not yet been acknowledged. We can click through this section to filter our list of batteries according to the fault type, and once we are done, we can return to the default view by selecting Clear Filters. This concludes Part 9 of the Venom BCMS video tutorial series. Please see the description below where we have provided a link to Part 10 of the series, where we will take a closer look at the information that is available for each battery, including activity records, maintenance, and fault data. Until next time, safe charging.